Welcome to the Shadowsoft Managed BRMS and RTI test drive on Amazon. In this tutorial, you will experience the Red Hat JBoss Business Rules Management Suite, Red Hat JBoss Operations Network, and OC Systems RTI product. The unique product combination of John, BRMS, and RTI allows detailed monitoring and management of your business rules, workflow processes, and operating environment. Through this tutorial, you will interact with the sample application deployed in the environment, called Red Hat CoolStore, while exercising tasks normally appropriate for the following roles: Operating Systems Administrator, a Business Rule Developer, a Business Rule Analyst. We'll try to note which role you're performing during the tutorial. The division of role activities helps to showcase the utility of the Managed BRMS and RTI products as a solution package appropriate for your business rule and process management needs. When you received your test drive activation email for the Shadowsoft Managed BRMS and RTI test drive, you'll notice that inside there's an IP address to access the externally facing server, which is running a Windows environment and holding the tools and resources you will use to execute the tutorial. So first you'll need a VNC client. In my case, I'm using the Tight VNC client from tightVNC.com. There is a native Windows client, and for a Mac or Linux, and this is a Mac, there's an executable Java client, which requires an installed Java runtime. So let's connect to the remote system. So here I have the IP address, which was sent to me in my email. So I'm going to connect and use the password test drive to authenticate to the server. And this brings me to Windows Remote Desktop Session. So within here, I can press Ctrl-Delete to log in. I'll select the RTI user and enter test drive again as the password. Once my desktop loads, I can see that I have icons to launch the RTI product console, a Firefox icon to launch the BRMS CoolStore web application, another icon to launch Firefox with the JBoss BRMS administration application, and finally an icon to launch the JBoss Operations Network web console. Now that we've achieved access to our systems, let's take a little bit of time to understand the business and technical objectives for the Red Hat BRMS product. So generally, business process and rule management is embraced by IT organizations and business to achieve business and functional goals to reduce IT spend, increase visibility to business process and business rules, and enable key performance indicators reporting for information events occurring within business process workflow and rule executions. So let's open up JBoss BRMS. So when I launch the browser here, we're connecting to another server within our Amazon Virtual Private Cloud. So I'm going to log in to that with the password admin, and of course the username admin as well. Now you notice right now we're in an empty knowledge base, an empty BRMS instance that's really not been used before. So this is your instance to play with. So we'll start by importing a repository. Because we're using the BRMS CoolStore repository in our demo, we're going to import that repository into BRMS here. So we'll browse, and within the remote system there's a BRMS CoolStore repository export. These are delivered as zip files. So we'll import that now and affirm that we want to do so. Okay, so now that it's imported the new repository, it's going to refresh our window here, and we can find the new imported resources within our knowledge base. So we'll expand packages, expand COM, Red Hat, and CoolStore. Now this is the default view of what kind of resources you'll find within a repository. So we have business rules, technical rules, DSLs for domain-specific language, any sort of models that are applied, which is our fact model, processes representing BPM or business processes, any sort of test scenarios that we've created for our package, any other assets such as items that can be loaded from the web, and any work item definitions. So let's expand our business rules and just kind of explore just a little bit. So we see here we have a total of 4 different business rules. Now one of those is a little bit special, and that's the shipping rules, and you'll notice that has a different icon that looks kind of like a table. So if we open this one for our shipping rules, we'll see that in fact this does render out as a table. And this table defines our shipping tiers 1 through 5, and based on a total value of a shopping cart, we assign a total for the shipping. So it's a very simplistic rule, but what's important to note is that how easy this is to not only understand and to modify by someone like a business analyst. So we'll close that, and we'll take a look at an actual rule. So let's look at applying a free shipping promotion. So this renders a when and then condition, which is typical syntax for a business rule. So when a customer spends $75, then execute a special command called apply free shipping. If we view the source of this, we can see that in the mval rule syntax how this rule is actually written. So a developer could write the rule this way, or he could author it inside of BRMS directly using the guided editor. So this identifies a rule, free shipping promotion DSL, which is the name we saw on the previous screen, a rule flow group called promo rules, which will be important in a later phase in this tutorial. It identifies a no loop attribute of true, which means that as business objects or facts within the rule memory space change, this rule will not execute more than once. It's in the mval dialect, which is the default dialect for business rules in BRMS. And here is the when and then condition. So when a variable SC of type shopping cart has a cart item total of greater than or equal to 75, this unit is measured in dollars, then inside of that shopping cart object, execute the set shipping promo savings method for the shipping total multiplied by -1. So essentially that means to assign a promotional value which is equal to the negative of the shipping. So if shipping was $8.99, this would assign a credit of $8.99 into the order. And that then sets the shipping total value to 0 and updates the object's order in the memory space. Okay. So within our model here, we have our Red Hat Cool Store fact model, which if we were to open this one, we can see that fact models are uploaded as jar files. So a developer that's identifying a fact model, whether that's reverse engineered from a database model or created directly by a developer in something like the BRMS Studio, based off the JBoss Developer Tools platform, would be able to upload a jar file containing all of the current fact model. You can also download the fact model and import it into a designer. Inside of the processes, we'll find the pricing process, and this is a BPM process. So we'll open that. The BPM process will take a little bit of time to initialize the first time you run it, as you would when you're just receiving your access to the virtual private cloud. And that's due to loading a number of web environment resources in order to enable live editing of a business process within the browser here. So rather than having special tools installed on your desktop, you can actually edit the process online within your business environment. So while that loads, we'll take a look at some other resources. So here are the test scenarios. So test scenarios are used to assert that your rules do in actuality what you intend them to do. So for example, applying the free shipping promotion that we looked at before, we can open this test process, and tests all follow a different syntax. So like rules follow when and then, tests follow given, any sort of execution of a method, which is not required, and an expectation. So when you're activating a rule flow group, such as promo rules, as you see here in the center, you intend to give a current state of a fact model. In this case, we're talking about shopping carts that have particular values in them, executing the rule flow group, and expecting that one shopping cart receives the free shipping promotion and the other one does not. And we'll see the criteria here is that this shopping cart that should receive the free shipping promotion has a cart item total of $75, and the shopping cart which does not has a total of $74.99. In other words, 1 cent below the limit. So if we were to run this scenario, which you can do live, you can also modify the scenario, add additional fact model objects, change its values, or change the expectations. So we'll allow that to build and run that test case. And we see that it passed 100%. In addition, it gives us in a summary which rules were activated and how many times. So in this case, our free shipping promotions DSL rule was activated once. The shopping cart object that we initialized with $75 now has a shipping total of 0. And the second shopping cart object that we initialized with the value of $74.99 has a shipping total of $10.99, which is what we assigned. Okay. So let's take a look back in on our pricing process, and we can see that all the resources have loaded now. If we shrink up our left-hand bar here, and pardon this tutorial slightly in lower desktop resolution than you may in actuality be running, you can see that you have a full BPMN, or Business Process Modeling and Notation version 2 palette, which includes any sort of activity as well as any sort of normal BPMN flow tasks like gateways and junctions. So we see here we have the steps within our process, starting with apply cart promotions, our shopping cart, calculating shipping, and applying any sort of shipping promotions. If we expand our properties view to the right and select apply cart promotions, we can see that this is a task type of a business rule. So in fact, all 4 of the process steps are business rule executions, which is signified by the table icon in the upper left of the activity. If we expand the extra, we can see the rule flow group that's activated. So when this activity executes within the BPMN process, it runs the rule flow group promo cart rules, which we took a look at earlier. So in addition to editing processes, managing your rules specifically, you can also validate the entire package at once. So for example, if you want to execute each and every test case in the entire Red Hat Cool Store package all at once, you could go to the QA tab, click Run All Scenarios, and see that validate that they all pass. So this is very useful for performing regression testing after you've made changes to rules or processes. As well, you can take a look at the analysis of the package and find things that are of note. So for example, if your rules cover or your test cases cover a positive condition but not a negative condition, then the analysis process will catch that. So we'll wait for it to analyze our package here. Generally, running the tests and the analysis on a package is a good first step to do whenever you open a package for the first time or import a package for the first time. So you can see our analysis found no errors, but it did cover 2 warnings. So our rule base covers a shopping cart, but is missing when a shopping cart is not actually present. And that's, of course, by designing the application, you're only going to be executing activities on a shopping cart when and if you have one. And it covers having an item in your shopping cart, but it is missing when you don't have an actual item in the shopping cart. And again, by designing the application, you're only executing the rules whenever you do have a shopping cart with an item in it. But if you had an application which could potentially need to activate even if a shopping cart or item were not present, so something was operating on a timer or operating on some other click event where a session could later become invalid and expire its data, you may in fact want to cover those rule conditions. Okay, so with that said, let's actually close this out and take a look into our Cool Store application itself. All right, so having explored JBoss BRMS from the administration side, Let's take a look at a sample application which is using BRMS in order to perform its business logic. So that would be the BRMS Cool Store, which we have an icon for on our desktop. So we'll double click that. And this will launch our web browser again to the BRMS node inside of our virtual private cloud and load our Red Hat Cool Stuff store. So this is a pretty simple store. There's no actual checkout feature, as you'll notice, but it does support adding items to cart. And via an AJAX method back to the service, it will calculate any sort of promotions for the total of the shopping cart items as well as the total of the shipping, and then calculate our cart total. All of these actions are actually being performed by the rules in BRMS and modifying the fact model, which is a shopping cart full of item entries. So let's start by adding a red fedora, a solid performance polo, and a vortex tumbler for when we get thirsty. We'll click add to cart. And we'll see the little spinner in the upper right when it's actually communicating back and forth with the server. And we'll see that we've added $50.04 worth of items into our cart. We've applied $8.75 to item promotions according to our rules. And we have $6.99 in shipping. But because we're not over $75 in our cart items, we're actually paying the full cost of that shipping for a cart total of $57.03. Now it clears out our selection so that we can add more than one. So in order to bump us over 75, let's add another red fedora. Click add to cart and we'll see our totals go up by $34.99 to $76.28. We received $17.50 in promotions. Our shipping is now 0 because we've got an $8.99 promotion for that. And so our cart total is equal to our item total of $76.28. We can clear our cart and do this any number of ways. And we'll always come up with a result in accordance with our rules. So very good, simple web application communicating with AJAX back to BRMS. In your Shadowsoft Managed BRMS and RTI test drive, there's two components that operate outside of the BRMS product to provide management, monitoring, and transaction inspection within the environment. One of those is the JBoss Operations Network, also called JON, which can be accessed by double-clicking the JON console icon on your desktop to open Firefox at the JBoss Operations Network Management GUI. So we'll log in with the username rhqadmin and password rhqadmin. So the first screen displayed is the JON dashboard. Now this has overall details of your managed environment, including the number of platforms, such as JON itself and BRMS, any other servers, services, or current alerts. So we can see here in our recent alerts on December 25th, Christmas Day, we had an operation execution failure, and a resource involved was the storage service. And so these kinds of things are normal in a virtual private cloud when you can start and stop your systems at any time. So if we access our platform, which you can also go to by clicking Inventory and choosing Platforms on the left, we can see our BRMS server and our JON server are both indexed here. So they're being automatically discovered, and they're confirmed as having availability to access them. So we'll click our BRMS server. Okay. So this is a dashboard of just the BRMS server. So we can see any sort of resource alerts, the current measurements of memory, swap space, the current system load, and so on and so forth, and any listed operations that were scheduled on this server. Operations can be scheduled through JON, which include restarting the server, changing its configuration, reloading configuration, performing a list of processes that are currently running on the server, and gives a high level of utility compared to logging into the server and executing those commands manually, particularly if you have a lot of servers in your environment. In the case of our virtual private cloud and our test drive, it's mostly for demo purposes since we just have the one BRMS server and the one John server anyway. Okay, so we'll select the inventory on the BRMS server. Then we'll select the agent menu. And so here we can see the BRMS server agent, which is loaded on the BRMS server 10.1.1.12 and running on its port and its status and communication. Now, if we look at the monitoring tab, we can find more information about the actual memory space used and such on the environment. We can see the last known measurement, any alerts, and over time what a running average is along with the available minimum and maximum information on this platform. So again, this is much more powerful in a large environment. If we select our frequency of metrics to 1 minute, we can get a little bit more useful information. So we can say within the last minute, our actual free memory is ranged between 250 and 301 megabytes, with an average usage of 278.8 megabytes. And likewise, our used memory is the converse of that at 1.5 gigabytes at minimum, up to about 1.6 on max, and averaging about 1.58. Okay. If we wanted to tweak our configuration, we could use the schedules, which identifies how often to collect any one of these particular metrics. So we can see, for example, that actual free memory is measured every 10 minutes. If we wanted to keep a close eye on a particular environment, let's say it was a production environment or a disaster recovery environment, we could increase or decrease this kind of measurement appropriately. If we look at our Operations tab, which is where we can schedule certain events to occur on the server, then we can look at the history of any operations since none are currently scheduled. And we can see that back on December 5th, we had auto discovery processes running. On December 10th, we looked at the process list. And so let's experiment with that, and let's actually pull the process list running on BRMS right now. So we'll go back to Schedules, select New to create a new schedule entry. We'll set the operation as View Process List and set it to a calendar date of now. So we'll go ahead and schedule that. And we get a confirmation that our operation schedule has been created and the status is complete. So if we double click this item, we can get a bit more information. So this is the list of processes that we're running. So starting all the way back from init, which is the first process that starts up on a Red Hat Enterprise Linux box, and all the way down to the named processes like, for example, Java, and what its memory usage and such is, and down to the universal device daemon, the current gettys that are running to supply terminal access, and so on and so forth. If you had additional processes running, like an Oracle process or MySQL process, even your SSHD process, and you wanted to validate that you didn't have a runaway process consuming a lot of memory, this would be one way to do that easily from within your system and be able to produce a report of this information later on. Okay, so that's a very brief tour of John. And this is looking at the server itself in BRMS. And one more thing we want to look at is the actual JBoss AS7 standalone server, which can be accessed within the BRMS server platform. And select the EAP node within that standalone. If there were multiple standalones or multiple domain environments here, then we would be able to select from them. So we can take a look at the summary of our EAP node here, and we can see any particular alerts or measurements or operations that were being submitted on this node. And luckily, we don't have any current alerts right now. Okay, so that's a very brief tour of John, JBoss Operations Network, and we will be taking a look at other monitoring capabilities we have in our environment next. The other monitoring tool we can find in our test drive is called RTI, for Root Cause Transaction Instrumentation. And there's two ways to access RTI. The first one is through John. So we'll start with that by double-clicking the John console icon on the desktop to open John. And like before, we'll log in with RHQ admin and RHQ admin. Now, similarly to how we view the BRMS platform and view information that's reported directly to John through the native John integration, we can also view the RTI tool integration in our platform. So we'll go to Inventory, select Platforms, and navigate to the BRMS server platform. Now, where we would have otherwise selected the BRMS server root or the JBoss AS7 standalone servers menu items here, and this time we're going to go into the RTI installations tree, expand RTI Enterprise, and RTI Collectors. Now, this collector is automatically started when RTI is loaded and connected through John and installed within a JBoss application server environment, in which case we have our BRMS server here. So we can select this collector and see a dashboard in John for this collector. So this naturally includes the normal stuff like we're accustomed to seeing, like resource measurement and resource operations. But it also includes the metrics that are being collected and any sort of package history relative to the collector configuration. So if you've been exercising the demo steps thus far, you will have RTI events in your metrics. If we further expand the RTI transactions, we can see detailed measurements that have occurred on the environment, such as access to the BRMS console, the BRMS Cool Store demo, and the Governor repository where all of the rule packages are being loaded from. All right. So in addition to being able to view certain levels of information inside of John itself, RTI provides a well-integrated tool that actually runs on a desktop. And so to access that, we're going to minimize our browser and execute the RTI console. So the RTI console tool is based on Eclipse and includes everything you need to do lightweight profiling on your applications, as well as deep dive tracing, collecting and analyzing RTI performance data. So on startup, it always checks for your current license values in your RTI, and because you're running within a test drive instance, all of that we have set up for you. Okay. So now within the RTI console, we see three main areas, right? The welcome page containing a number of quick links for common workflows that you might want to do within RTI. The collectors view, which are connected to hosts accessing an RTI profile and any sort of deep dive trace data you have. And the RTI workspace, where we can store saved RTI performance data locally, exchange it with other RTI users in order to enable a team approach to troubleshooting performance and transaction information. So in this case, we have some pre-populated data with a current connection to the JBoss BRMS server, in which we can look at our sample profile and deep dive data. So we'll select the BRMS server in our collectors view. Then we're going to expand the RTI installations and the BRMS Cool Store demo collector. And here in RTI Workspace, we'll expand the Saved Trace Data node. And here we can see the saved data sets from traces that's been occurred inside of your test drive. Okay. So if we double click any of our saved traces, we can pull up information about that trace, including the overview of transaction events, the overall list of events relative to the heap, any sort of metrics that are collected in transactions that were performed. And as well, we can see that within the application, at what time and how long did it take for any particular event to execute. So from the welcome screen, we'll select View Transaction Profile Snapshots, and we can select our JBoss BRMS Cool Store demo. Select OK. And here we can get our snapshot information. So here's our collector resource metric view and our platform resource metric view. So this one is monitoring the Cool Store application, and this one is monitoring the BRMS server as a whole. And here we can see the time in milliseconds that it's taking for transactions to process within both. And on the right, we have the percentage of transactions as they're relative to user load and system load. Okay. In the upper part of our window here, we have the actual transaction details. So you can see, for example, an HTTP servlet request into the Governor repository took 33% of the time within a transaction. If we expand that, we can see that 11% of the time was spent in our JBoss seam intercept method in order to actually populate our bean here. And most of our other tasks are actually fairly fast. We can see a JDBC task connecting to our local database took 19% of the time of the transaction, where most of that time was actually spent within Hibernate. Let's see. So now we will select the UIDL transaction just a little bit further up. And again, pardon the low desktop resolution of the demo in order to make sure everything fits on the screen. Okay. We can see here that 19% of the transaction time was spent within the GWT. And this is the event that occurs whenever you click Add to Shopping Cart and is representative of the AJAX event that actually gets posted back to the server. Okay. If we go back to our top level UIDL event there, we can actually right click and say start a deep dive performance tracing session. And here we're given a list of all the available events or endpoints which are known to RTI at the current time. So here we have the ability to look for specific boundaries relative to the transaction. So for example, not including anything for troubleshooting that executes in less than 10 milliseconds, and tracing for the next 1 minute. So at this point we can click Start Trace. And it's going to connect to our BRMS server, connect to the RTI agent running there, and configure it to run instrumentation on that server. So now that trace is running, we'll click Finish. We can minimize our RTI console, open up our Cool Store, and now attempt to actually cause some events to execute. So go ahead and add some items to the cart, add a few more, clear the cart, check them all, add to cart, and clear the card again. And now coming back to our RTI console. So now we'll open our saved trace data here. So that opens our BRMS cool store trace, where we've measured quite a number of transactions, 194 over 734 events. So all of these transactions include servlet transactions, DBC transactions, so on and so forth, anything that can occur within the BRMS system. So we'll take a look at maybe one of the longer lived ones, like this one, that was lived for about 13.5 milliseconds. And we can see here what our JVM heap looked like at the time, what other transactions were related, such as execution of the BPM process. So these BPM process, node follows, node triggers, the process start and stops. The rules fire rules event was executed 3 times. Insertion of facts into the model was executed 18 times. And here we have our JDBC methods, where at the very most we had 344 queries executed over the life of this set of transactions. So what can be useful if we increase our view here, we can see all of those categories here in the event class. Okay. So now, having seen RTI, we can make a bit more sense of what occurs within John. So here, if we were to look at the BRMS console, RTI transaction area within John, we could see the different facets of information that would have been collected for that, including the average response time, transactions per minute, and total transactions per minute, any failed transactions. So let's open the cool store. Okay. And over the last minute, we've had an average response maximum of a little over 18.5 milliseconds, with an average of about 0.24 milliseconds. And we had no failed transactions, but a total transactions per minute max of about 17, but averaging about 1 transaction every 4 minutes. Okay. So naturally, the best place to view real critical transaction level data is in the RTI console. So this is the tool that developers would use to be able to troubleshoot a problem, for example, a bug in the code, or a bug in the network, or a bug in a downstream system that was causing transactions to take longer than usual or fail more often than they should. Okay. So that's a very high-level demo of RTI for MOC systems. But the main point of this tool really to recognize is the level of utility it provides a development team or an operations team in being able to perform deep transaction inspection within your environment. So throughout this tutorial, you've taken a tour of Red Hat's JBoss Business Rules Management Suite, exercised the management features of Red Hat's JBoss Operations Network, and explored OC Systems' root cause transaction instrumentation product. So as we detailed, it was only really a scratching of the surface of what's possible with these tools. There are several resources you can access for further information, starting with the Red Hat Customer Portal, which you can reach at access.redhat.com. And from there you can explore the products, such as the Red Hat JBoss middleware product, and within JBoss integration and BPM products. This is where you get access to the knowledge base for JBoss BRMS and the upcoming products like JBoss BPMS. There's as well videos on the products and product documentation for not just the business rule management system, but also related products like JBoss Surface Oriented Architecture, Fuse, or AMQ. Again, within the products, you can select the Red Hat JBoss middleware and JBoss management to learn more about JBoss Operations Network. Likewise with the knowledge base and videos, as well as product documentation for the various versions of JBoss Operations Network. For RTI by OC Systems, go to www.rtiperformance.com and access the information about RTI, including reasons that you may use it in your team, the new updates on the releases, and to schedule a personal demo on site or read additional information or watch videos of RTI in action. Now naturally, as your test drive is operated and produced by Shadowsoft, the open source systems integration experts, please visit our site, contact us, and we'll be happy to help get you set up in a POC environment of your own. As well, you can take increased advantage of our test drive and test drive-like services. And we can provide the licensing and integration with Red Hat and RTI and deliver an integrated solution for your enterprise. So all of that said, take care. We hope you've enjoyed our test drive video on Managed BRMS with RTI.